Hi everyone! Today we're going to be talking about operations with integers, and specifically we're going to learn how to define an integer, then we're going to add integers together and subtract integers. So make sure you've got out your math notebook so that you can take notes and use them when working on your class. So first we're going to start with defining an integer, and a basic definition would say that integers are all of the whole numbers and all of their opposites on the positive and negative number line, including 0. So basically, we're looking at numbers that are not fractions, not decimals, whole numbers, and their opposites. So we can include negative numbers here, but again, no fractions or decimals. And 0 is also an integer. So positive numbers, we know about these. These are greater than 0. So if we look on the number line, they are all the numbers that are to the right of the number 0. But we've also got negative numbers, which we're going to talk about on the right-hand side. When we get to those, we're going to use a different color to represent them. So here we've got our clear boxes that we're going to use to represent positive numbers throughout this lesson. So for example, if I wanted to draw the number positive 3, I could draw 3 clear boxes to represent it, or 3 white boxes. Negative numbers are all of the numbers that are less than 0. So on the number line, they're the numbers that are to the left of 0. As we get more negative, we're getting to numbers that are lower and lower. The numbers that are greater are as we go increasingly to the right on the number line. And like I said, we're going to use red boxes to represent negative numbers. So if I wanted to draw out the number negative 3, I could draw 3 red boxes to show that they're negative. And there's an important fact that you need to know, and that is that when you add a number and its opposite, the answer is 0. So for example, if you have a positive 6 and you add a negative 6 to it, you get a 0 for an answer. And that's kind of because, if you want to think of it this way, the two numbers cancel each other out. It's like if you have $6, but you also owe somebody $6, you really have $0 once you pay the person back. And so that's really what it means to cancel out with positives and negatives. You could switch them around. You could have a negative 6 and then add a positive 6 to it, and you'll still get 0. And so if I were to draw this, here's an example of six regular clear boxes. But if I add 6 red boxes to it, they kind of cancel each other out, and I'm left with none left over. Okay, so we're going to be using this method of boxes as we go through some examples of adding and subtracting integers now. So when you add integers, you should notice which numbers are positive and which numbers are negative, and think about that when you're canceling out the numbers. So I'm going to go ahead and draw out this problem, negative 3 plus 5. The negative 3 would be 3 red boxes because it's a negative number, and then we're adding 5 to it, which the 5 is positive, so it's 5 clear boxes. And notice that the negative 3 and 3 of the clear boxes cancel each other out, but I'm still left with two clear boxes. So negative 3 plus 5 turns out to equal 2 as an answer. Notice how it's kind of like doing 5 minus 3, right? Because when you minus 3, that's kind of like a negative 3. You're taking it away from the 5. So we took away 3 from the 5. But we had more of the positives than we did of the negatives. So that's why we're left with a positive answer. So here's another problem. This is negative 9 plus 7. Okay, but I'm going to go ahead and start with the negative 9, which is 9 red boxes. So if you count those, there's 9 of them there, 9 red. And then I'm adding positive 7. So I'm going to put down 7 clear boxes. And then my 7 clear boxes cancel out with 7 of the red boxes. And I'm left with 2 red boxes. Or in other words, I had more negatives. And so I'm left with a -2 for an answer. So again, I kind of subtract the two numbers, even though it says to add them. Because of the canceling out that's going on here, I'm doing 9 minus 7, but then I actually have extra negatives, not extra positives. So my answer is going to be negative. All right, here's another example. This one's a little different though. This one has a -4 for the first number, and then we're adding a -3, which is still red boxes. So here we've got the same sign, both negative numbers, and we're adding them together, and so we end up with 7 red boxes. Okay, so we've got -7 for an answer. This one, we didn't subtract the 4 and the 3, we added them. And so instead of thinking about rules like adding, subtracting, keeping negative signs, or keeping positive signs, I'd like you to think about it more in this way of how many negative numbers do I have here, or how many negative units do I have, and what am I adding to that, and what am I left with at the end? Okay, so drawing it out is actually a really great way to practice these problems. So I've got 3 problems here for you, and I would like you to try them out on your own. So you're going to need to pause your video, and then once you're ready to check your answers, unpause your video, and then I'll show the answers. So I'll give you a few seconds to pause it right now. Okay, so for this first one, we have more positives than we do negatives. So if you drew it out, you'd have -3 or 3 red boxes, and then you'd have 6 clear boxes or 6 white boxes, and 3 of each type would cancel out, and you'd be left with 3 clear boxes as a leftover. And so we have 3 as a positive number for an answer. The second problem is different because if we were to draw it out, we'd have 4 red boxes, and then we'd also have 2 more red boxes, so we're left with 6 red boxes, or a -6 for an answer. And then this last one, we have 5 clear boxes, and then we're adding 9 red boxes to that. And so we have more red boxes than we do clear boxes, and to be specific, we have 4 extra ones left over once we cancel things out, and they're negative, or they're red if we were to draw it. So those are our answers. Okay, so that is it for adding integers together. So now we're going to talk about our last objective, which is subtracting integers. And I want to give you a strategy that maybe you haven't heard of before. And that is that subtraction is really just addition in disguise. So let me explain what I mean. If you see a subtraction sign, you can change the problem to adding the opposite. So here's an example of a subtraction problem. You already know the answer to this problem. 6 minus 3 equals 3. But you can do it in this new way where you can say, instead of subtracting, I'm going to make it an addition problem, and I'm going to add the opposite. So see, right now, this looks like subtracting a +3. But I'm going to move that around. I'm going to add the opposite of 3, which is -3. Okay, so I'm adding the opposite of the +3, and I've now got 6 plus -3. And remember, if we drew that out like we were doing before, we've had 6 clear boxes and then 3 red boxes, and then we cancel things out, and we're left with 3 clear boxes, or a +3 as an answer. And of course, you already knew that, right? 6 minus 3 equals 3. We got the same answer both ways. So this is just another way to think about subtraction. And it's helpful for different types of problems, such as this. So here we've got -7, and we're taking away 4. Well, if we change it to an addition problem, then that's going to be something we already learned how to do. So let me show you. If we have a negative 7 and we want to make it into adding the opposite of 4, that would look like this. Adding, whoops, we lost it. Adding the opposite of 4. So when I say opposite of 4, I'm putting in a negative sign in front of the 4 because that's the opposite sign of what the 4 says. So instead of positive 4, I'm now writing negative 4. So we are adding the opposite of 4. So now we've already done problems like this with addition. And so we've just created something that we already know how to do. So we would have negative 7 plus a negative 4, which is 7 red boxes, plus 4 red boxes, which is 11 red boxes. So I have a negative 11 for an answer. Now, if you don't like this way, I'm just going to show you really quick one other way to think about it. If you had negative 7 on your number line, and you wanted to take away 4, that would mean you go to the left 4. That's what take away really means. You start going to numbers that are smaller. So we would go left 4. So we would go negative 8, negative 9, negative 10, negative 11. So basically start at negative 7 and then count 4 to the left, and that's where the answer is. So that's another way to do it. Negative 7 minus 4 puts us at negative 11. Okay, so I have a couple more problems for us to practice. Here's one where we can add the opposite. So notice this is 5 minus negative 3. But instead of putting a minus sign, I want to make it an addition sign. So I'm going to do that. And then I have to add the opposite of negative 3, which means I need to make it a positive 3 now. So add the opposite. Keep those words in your mind as you do these problems. So now I've really got 5 plus 3, and voila, I know how to do that problem. It's just, oops, it's just 8. We don't need any boxes for that one. Okay, let's try one more of these like this. And that is negative 3 minus negative 9. This one's kind of like the first one. Now, the one we just did. This symbol here is a subtraction symbol, right? And that's the one that I want to turn into an adding symbol. Okay, so I'm going to change that to adding, and then I'm going to add the opposite of negative 9, which is a positive 9. So add the opposite of negative 9. Okay, so now I've got negative 3 plus 9, and this is one of those addition problems where if we wanted, we could put some boxes down. Remember 3 negative or 3 red boxes, and then 9 clear boxes to represent the positive 9. Cancel things out, and I'm left with 6 clear boxes, or a positive 6 for an answer. So notice how these two numbers are related. The negative 3 and the positive 3 cancel out, and I'm still left with 6 positives. Okay, so here we are at our practice problems again. And so I'd like you to pause your video one more time, and then I will go ahead and put up some work here for how to think about these problems. All right, hopefully you've worked out your problems and you have added the opposite on each one. So please double check your answers. And as always, if you have extra questions on these problems, just send me a message and we can go over them. All right, I wanted to just end with a little bit of explanation about where we see negative numbers in real life. So we do use negative numbers with temperature. You've heard of things like negative 2 degrees or negative 10 degrees. That would be pretty cold if we were dealing with Fahrenheit. So we definitely see negative numbers there. Here's another example. We use negative numbers to measure below sea level. So 0 would be sea level, and then anything below sea level would be a negative number. And of course, this is the one I always think of, is showing debt, and let's say that you buy a car or your parents buy a car and they had to get a loan from the bank for $5,000. Well, since they owe the $5,000 to the bank, that would be shown with a negative number. Or in some cases, if you were looking on the computer, they might even use a red number to indicate the debt. And so, again, we see these negative numbers all the time in real life. Okay, so that's it for today's lesson. Thank you so much for watching. And these are the 5 quiz questions that I would like you to answer. So please open up a message to me or an email and type in your answers to these 5 questions. And if you have any questions about this lesson or anything you're working on, please feel free to let me know.